On December 22, 2018, a massive wave struck the coastlines of Java and Sumatra. It claimed over 400 lives and shattered entire communities in a matter of minutes. But the most terrifying aspect of this disaster was the silence. Unlike typical tsunamis, this wave arrived with no warning sirens and no preceding earthquake to alert the people in its path. The source was eventually traced to the Sunda Strait, where a massive section of the active volcano Anak Krakatau suffered a structural failure, shearing off directly into the ocean. For a 300-meter-tall volcano to suddenly fail like this points to an instability that wasn't a freak accident, but something baked into the island's very foundation. In volcanology, when the steep side of a cone loses its internal stability and gives way, it's called a flank collapse. This diagram shows the physics of a silent tsunami. When millions of tons of rock plunge into the sea, the mass instantly transfers its kinetic energy into the water, displacing it into a surface wave. Because the wave is caused by falling debris rather than shifting tectonic plates, earthquake sensors often record nothing until the water hits the shore. To understand why Anak Krakatau was so weak to begin with, we have to look beneath the waves, at the ruins left behind by its predecessor. In the summer of 1883, the original Krakatoa volcanic complex had been quiet for over 2 centuries, but cold seawater was steadily leaking into a vast magma chamber deep beneath the strait. This mixture turned the entire island complex into a geological pressure cooker. On August 27th, that pressure was released in a sequence of colossal detonations that ripped the island to pieces. The largest blast generated an acoustic shockwave so intense it was heard clearly 4,800 kilometers away and circled the entire planet 4 times. Krakatoa blasted 21 cubic kilometers of rock into the stratosphere. The resulting sulfuric acid aerosols dropped global temperatures by 1.2 degrees Celsius and caused years of blood-red sunsets around the world. The 1883 explosion left a lasting physical hazard. As the island collapsed into the sea, it created a massive, steep-walled underwater basin, a submarine caldera. The system lay dormant until 1927, when underwater eruptions breached the surface to form a new island, Anak Krakatau, the child of Krakatau. Supplied by a steady flow of basaltic magma, the young volcano grew aggressively, adding several meters to its height every single year. Anak Krakatau wasn't building on a level seafloor. It was growing directly on the precipitous rim of the 1883 caldera. As the cone piled upward, its massive weight pushed the center of mass further out over the deep, empty space of the underwater basin. By 2018, the southwestern side had become too heavy for its foundation. With growth outpacing its structural integrity, the collapse became a physical certainty. The 2018 failure left the island physically unrecognizable. It lost roughly 2/3 of its volume, its peak shearing down to 110 meters. This shift relocated the volcano's plumbing. The active vent now sits within a newly formed, sea-filled crater bay. But the volcano did not retreat. It immediately entered a new constructive cycle, generating fresh lava and ash plumes as it works to rebuild its profile. This constant threat has turned Anak Krakatau into one of the most intensely monitored open-air volcanic laboratories on Earth. Specialists track its every movement using ground-based seismometers, sulfur dioxide sensors, and real-time satellite radar. The volcanic system, born in 1883, remains a volatile, active engine. Understanding its cycle of growth and failure is the only way to protect the populations lining the Sunda Strait from whatever it does next.